particular integral of differential equation with constant coefficient whenever the non-homogeneous function is of this form, that is x times of some function of x. So in that case, the particular integral is evaluated with the help of this formula. It says that keep this x function as it is, take the operator form over the function of x, that is v, minus take the derivative of operator with respect to d divided by operator square into whatever the function of x we have in question, take it up over here and operate this operator on this v. Let's understand with the help of this example. The question is find the particular integral of this differential equation. So with the help of this formula we can write particular integral is equal to, so this is x into sine x. Now in this case the function v is sine x. So we will keep this x as it is. 1 by operator form, that is d square minus 1 into v. V is a function, that is sine x, minus first order derivative of the operator form, that is the 2d in this case, divided by square of this term, that is a d square minus 1 whole square into sine of x, that is a function of x v. Now from here we can write x times of, operate this operator on sine x. So in case of sine x, so d square is replaced as minus a square, where a is a coefficient of x in this case. What is the coefficient of x in this case? That is the 1. So we replace d square by minus 1. So we have minus 1 sine x minus 2 times of operator d into sine x divided by. So first we are dealing with the denominator term because we have same term over here. So we replace d square with minus 1 in this case. So minus 1 whole square, and rest of the terms are as it is. This is equal to x divided by minus 2 into sine of x minus 2 by minus 2 square is 4 d of sine of x. So d stands for the derivative with respect to x. So what is the derivative in this case? So this term is as it is, minus 1 by 2 derivative of sine x is, that is cos of x, and that is the final particular integral in this case. Next example is find the particular integral of this differential equation. In this case we have x into cos 2x function. Now apply that formula. According to the formula we have particular integral of this form. Now what is the function of d? So function of d is d square minus 2d plus x. So substitute this function d over here and take the square over here, and in a numerator we need to take its derivative. So what is the derivative of this term? That is 2d minus 2. So after substituting these values we have this form. Now we need to operate this operator on cos 2x, and same in this case this operator on cos 2x. So in case of cos we replace d square by minus a square, where a is a coefficient of x in cos function. So what is the coefficient of x? That is 2. So replace d square by minus 4. So after substituting d square with minus 4, we have this form, and the rest of the terms are as it is. Then simplify this, minus 4 plus 6, that is 2, and even in this case minus 4 plus 6 is equal to 2. So simplified form is equal to this. Next we can take the common as a negative sign from here, and then we can cancel it out, because when you take negative outside we have 2 minus 2d in a numerator case, and the same term is available in a denominator. So after simplifying we have this term as it is. Now here we have taken negative outside, so it will become plus. In denominator, we have only one factor because one factor is already cancelled with the term in a numerator. You can observe that this term that is same. So we can take it as x plus 1 into this term. In the next step, we need to remove d from the denominator. For that, we need to create a d square in the denominator. So what we will do, we have a minus b term. So we will multiply by a plus b in a numerator as well as a denominator, so that we can get a square minus b square, and automatically with this d will get removed from the denominator and we have d square in the denominator. So in order to create a plus b, we multiply by 2 plus 2d as well as divide by the same term. Now simplify this. After simplification, we have this term in the denominator. That is 2 square minus 2d whole square, that will be a 4d square. Now d square is replaced by minus a square, that is coefficient of x, that is 2 square. So we replace d square with minus 4. Substitute the value of d square as minus 4. We have simplified form is equal to 20 in a denominator. Now we can take 2 outside. Even you can take 2 from here outside. But it's okay. We can take the 2 outside from here. So after taking 2 outside, we have simplified form as 1 plus d by 10, because that 2 will get cancelled with the 20. After that we have a 10 in a denominator, cos of 2x. Now operate this 1 plus d operator on a cos 2x. How to operate this one? So we will take x plus 1 as it is, 10 outside, 1 into cos 2x, that is the cos 2x, plus derivative of cos 2x. So the derivative of cos 2x is minus 2 sin 2x. So this is the final particular integral in this case.